Welcome to the organic chemistry class. We are taking phenols and ethers. We will take whenever OH is attached to a simple benzene, such a compounds are called phenols. Even the simple, that is the pH stands for the phenyl with a ol, so therefore a pH OH symbol is given for the phenol representation. Ethers is simplest ether is a methyl plus O another methyl. This is called dimethyl ether. Dimethyl ether. And if a little bigger one, CH3, CH2, O, CH2, CH3. This is called diethyl ether. Diethyl ether. In fact, we have more, that is a typical example. In the case of phenols, we take ordinary phenol, and a typical example for the study of the ethers is a diethyl ether. This is also known as common ether or solvent ether. Both the sides we have ethyls, therefore it is diethyl ether, the nomenclature, and the rest we will take in the ether topic. Let us take first phenols. How these phenols are prepared? Preparation part we will take. We have four common methods are there. The methods which are common to the alcohols may not be suitable here. So, we have some special methods are there. The first method is somewhat common to the alkyl halides, but alcohols here the hydrolysis of first method is hydrolysis of chlorophenol. Hydrolysis of chlorophenol. Chlorobenzene, I am sorry, chlorobenzene. Or phenyl chloride or chlorobenzene. That is benzene, we are having here a chlorine here, that chlorine we are going to replace with a suitably with a OH group. You can guess what we have to take is a OH minus should be there to replace this Cl. But just taking the OH is not sufficient. We have to take the three different conditions. One is concentrated NaOH. Second one is a high temperature and high pressure. All these three conditions should be there. High temperature of approximately 350 degrees, that is not a big issue, but the high pressure is around 150 atmospheric pressure should be there. That is actually in the lab it is not possible. 150 atmospheric pressure in the laboratory we cannot maintain. Only industrially the method is possible. With all these concentrations, if you conditions, if you do it, a OH minus is replacing the Cl. It is a nucleophilic substitution reaction. Nucleophilic substitution reaction. It is commonly in the lab we cannot prepare. However, it specifications containing in the industry we can do. The process is also commonly known as Dow process. DOW, Dow process. It is a plural actually, Dow processes. Why plural? Means the temperature and the pressure you can alter. So, therefore, slight variations containing different methods are possible. All together we call Dow processes. But a specific method around 350 degrees and 150 atmospheric is a Dow process single method. Okay. Now, let us go for the second method. It is a hydrolysis of diazonium salts. Diazonium salts. Benzene containing a N2Cl. This is called what? A benzene diazonium chloride. Here you need not to do anything, just add some water and warm it. Heat with water or boil it for some time. Just boil it. The OH present here will replace the whole group. The N2Cl is a very labile or outgoing property containing group. Therefore, with a minimum of one OH, you need not to take base also. Just water will replace and you will get the phenol. Only thing is, where from this N2Cl you are going to get? It is a small problem in the benzene topic we have seen. Nitrobenzene reduction will give aniline. Aniline on diazotization with sodium nitrate and HCl at low temperature give this diazonium chloride. That on hydrolysis will give the phenol.